We haven't had a review for a while, so enjoy this look at the Antuino. It's a universal RF test instrument for various checks around the shack and outside with portable antennas. It sells for $109 US and the supplier is HF Signals, well known as the origin of the BitX and MicroBitX transceiver kits. What does the Antuino do? The most common measurement you'll probably do on it is VSWR, with an LCD display giving you a curve graphic. It can operate as a field strength meter. Also cable tests, for instance coax cable loss and cable velocity factor. You've got a modulation meter function, and it can be operating as an RF signal source. That's useful for testing various receivers and other equipment. Also, it can plot frequency response curves for crystal filters and bandpass filters. Again useful for tests around the shack if you're into construction. It's quite a big instrument, about the size of a house brick, and especially so if you compare it with a nano VNA, which is a fraction of its weight and volume. Only two controls on the front panel. The function switch, which is also the VFO and other settings, like for the menu system, and an on-off switch. On the right are sockets, an RF out and an RF in. Up here on the top is a DC power socket, though no mention of the voltage or polarity. And on the left we've got a connection for a USB cable. It's a fairly robust box, quite heavily built, and there's just 4 screws that open up the box. The batteries fit inside, so you'll need to undo those screws to get to the batteries. At first glance, the Antuino LCD green and black display is low tech and a generation behind the multicolour display you have on the Nano VNA. But here's something that's important for outside antenna work. The Antuino display is much more readable in bright sunlight than on the Nano VNA. In fact, the Nano VNA is almost unusable, and you'd need to put a towel over your head and get some darkness to be able to see much on it. Whereas here, in bright sunlight, the Antuino display is visible quite well. The first test with the Antuino will be with this magnetic loop. You've seen it before, I use it a lot on 10 and 6 meters. Antenna is connected to the RF in. I'm going to assume I don't know the resonant frequency of the antenna, so I've just gone for 40 megahertz. We need a wide span, so let's go to 30 megahertz. And we're in SWR mode. We want to exit, so we'll go to OK. And all we can see near the left is a little blob just on the display, around 28 megahertz. So this display isn't particularly fine, so we want to magnify this end of the display. So we'll instead go for a center frequency of 28 megahertz and a smaller span. Initially, let's go for 3 megahertz and then OK. And then we have a bit more of what you'd expect. It is still fairly coarse, and a magnetic loop is a fairly narrowly tuned antenna, so we'll go for a even smaller span. So here's our SWR curve. At the far left it's 28.3, and at the far right it's about 28.6, so we've got a 300 kilohertz span. Near the middle, got 28.475, and if you look at the top left, 1.4 VSWR, a return loss of 14 dB. Now we'll just take a look at the loop, and as you can see, it's sitting hard up against a timber fence. If I move it away from the fence, the center frequency changes quite a bit, up to 28.510. A UHF Yagi. Looks like it's centered on around 440 megahertz, so suitable for 70 centimeters FM. This time I've got it set up to power, not SWR. Span 1 megahertz and center frequency 1 megahertz. So, interesting thing is you can see the relative levels of signals. And the tallest down here is, I know it's the strongest station locally, on about 1377. I'll zoom into that later on. But something that's worth noting is that here we're in the center of 1 megahertz. If you look at the top right, the display measures the frequency. We go down, and for some reason the display shows 9.462, 9.384, and then 8, and then 7. So I'm not sure what's happening here. This should be frequencies below 1 megahertz. We'll try the FM band. What about coaxial cable loss measurement? Again, I can use the Antuino for that. I'm doing a measurement at 430 megahertz, and with a short length of cable and a few adapters, the reading is minus 36 dBm. I'll now connect in this longer cable and see how much more power I lose. Now it's minus 39 dBm. So we've lost about 3 dB just by connecting in this length of coax. Although it is RG58, so you'd expect quite a bit of loss at 430 megahertz. Here I've got a quartz crystal of unknown frequency. I'll try and use the Antuino to find out what it is. I'm using the SNA function, and I've set the center frequency at around 7 megahertz and given it a wide span of 10 megahertz. The Antuino has SMA connectors. It came with 2 BNC connectors, but you'll also find the BNC to banana connectors handy. Anyway, I've got the crystal connected across the 2 red connections, in other words the 2 inners of the input and output, and we'll have a look and see what the display shows. Around 3.5, 3.6 megahertz. So we'll zoom in even further. I should mention you do need to go to a fairly fine setting because the resolution of the LCD is somewhat limited. It's a very familiar pattern. You'll see this also if you try and test a crystal on a nano VNA. Frequency around 3.579. So it's obviously one of those common colour burst crystals and suitable for use on 80 meters. I'm not going to demonstrate it today, but if you have multiple crystals set up as a crystal filter or even tuned circuits, then you can also connect those up to the Antuino and be able to check its characteristics. Here I've got a homebrew attenuator in line, I built it for use with the FT817, so when I had 500 milliwatts going in, there was 100 milliwatts going out when I had the first section switched in, or if I wanted to go really low, I could switch in the second section and get only 20 milliwatts output. That is a power drop of 7 dB for each section. Anyway, we're now at minus 8 dB. I switch in one section, goes down to minus 13 dB. So that's only a drop of 5 dB according to this. I'll switch in the second section and we're at minus 19 or 20 dB. So according to this, each section is only attenuating by around 5 dB rather than 7 dB. Again, got it set up in SNA mode. This time it's sweeping only a 1 kHz slice on 7031. And as you can see, it's putting out a signal, so it's also a handy RF signal generator. This has been my look at the Antuino. As I mentioned before, it's $109 US from hfsigs.com. Thanks to Ashar Farhan, VU2ESC, for the review unit.